Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hey everyone, welcome to a brand new episode of the Clear to Send podcast. I am your co-host, Roel Dionisio, alongside our other co-host, Francois Vergès. How are you doing, Francois?
I'm good. Hey, Roel.
Hey, welcome.
Good to be back.
Yeah, welcome back to the show.
I know. It's like, where have you been?
Yeah, I thought
I was busy. Yeah.
You were traveling across the world. Your last end of year travels and trainings and conferences.
Yeah, it was a little crazy for me at the end of this year. I did a 3-week trip in Europe. And I came back home for a week, but I was like super busy.
Yeah.
And then I went to Australia for a week for another training and for the Wi-Fi design day organized by Ekahau. And I came back last night overnight. So I got super busy. So thank you for, taking care of the podcast.
Yeah,
I'm happy to be back.
Yeah, of course. And I know you went to Wi-Fi Design Day in Australia. There's been a couple of these in different parts of the world. What was your experience like going to Wi-Fi Design Day? It
was really nice. They always try to pick a nice venue, and in Australia we did it at the Sydney Opera House, which is pretty much whatever you see on the postcard when you think about Australia. Yeah, so they booked a room in there, and we had the view on the bay, on the bridge, and it was really nice. And then the speakers, they always have great speakers. They had Keith talking. I did a talk with Stephen Cooper on Wi-Fi 6, and we have different guys from Australia to talk. A great guy from Australia, so it was really a really nice experience. And it's because it's a local event. It's nice to see for local people to come and just to meet locally, with whoever is there in their country or region. So that you have this nice local aspect to it as well.
Yeah, pretty much. And I saw the photos. It looked like a great turnout. It was a really packed event, wasn't it?
Yeah, I think they had 100 people, I want to say. I don't know exactly how many people, but I would say 100 people. It was that was their second edition in Australia. So they, I think last year that was the first one, and then so they already knew how to organize the event. And the guy who organized it in Sydney, I think, organized it in Singapore like the week before.
Yeah. Okay.
So they did like 2 back-to-back in APAC.
Wow. Okay, that's great. Yeah, I did see photos of the one in Singapore, and that venue looked like it was a wedding. To be honest, it was like a really glamorous venue that they picked, and the decorations were pretty nice. And also, this one in Australia looked incredible. You're right in the perfect location to have an event. And what do you think was your favorite presentation out of there?
I don't know. A lot of them were great. I like the one from Dom. I forgot his last name, but he's a guy from Australia, and he talked about testing Wi-Fi networks. So doing a little bit more than the typical test we do, using heavier equipment, to test the load of a Wi-Fi network. I found that to be pretty interesting. So, and then Aaron from Aruba, he talked about the conference he supported, and the conference was pretty much a robot soccer cup. I think they call it the robot cup.
Yeah, I saw tweets about that, and I thought that was interesting because the robots are controlled via Wi-Fi, right?
Yeah, exactly. So the robots were controlled by the Wi-Fi, and he had to take care of it. And plus, it's an event, right? So he talked about all the challenges of, supporting Wi-Fi during an event, and I kind of relate to that. And I really like events as well, event Wi-Fi. So I enjoy these, and I like soccer. So
Awesome.
I enjoyed his presentation. Yeah.
Yeah. Soccer, of course. And you were watching soccer on the way home. I saw as you were writing your blog post. And I kind of want to mention that here too, because the blog post that you wrote recently was finding the data rate from a Wi-Fi 6 client, which I've been able to do using Wireshark and the Jetson Nano. You've been able to put that together in a blog post that really shows you what filters to look at and where to see that in the Wireshark capture.
Yeah, and building it, I was thinking that Wireshark should have that built in.
I think eventually they will. I've noticed as there's newer updates of Wireshark, they tend to improve what you can see with Wi-Fi 6 within Wireshark, because I remember I was trying to do a capture from the Catalyst 9115 using sniffer mode, and I was unable to see any Wi-Fi 6 data frames. And apparently there was some sort of bug in Wireshark that prevented me from seeing that. So when I updated to the later version, because I saw the release notes, I was now able to see those data frames. And that's awesome. It wasn't as detailed as, well, because it didn't include the radio tap headers, the Wi-Fi 6 radio tap headers that you see in the Jetson Nano. And I think that's where the Jetson Nano with the AX200 is just superior right now, is you get a lot more information that way. And I hope that we can get that from the vendor APs. But otherwise, I'm pretty happy with using the Jetson Nano. It's pretty flexible. It's small, but it does give us all the information, that's how you generated the content for your blog post, is using the Jetson Nano for those captures, right?
Yeah, so during the Wi-Fi Design Day event, I co-presented on Wi-Fi 6 with Stephen Cooper, and so he did a nice, presentation on the key feature of Wi-Fi 6, and then I talked a little bit about design consideration for Wi-Fi 6, and then after that we did a demo. So we did a demo that was similar to the one we did at WLPC. So we had like a Mist AP running a Wi-Fi 6 network connected to the internet, and we asked people to connect, people with Wi-Fi 6 devices to connect to that SSID, and then generate or launch a speed test, right, to generate some traffic.
Right.
And then we're showing the activity on the spectrum, and then I showed them how we could do a packet capture using the Jetson Nano. So I had the Jetson Nano on the table, connected to my computer, and I showed them how I configured the Jetson Nano to do the packet capture, and then how you can stream the packets back to your Wireshark on your laptop, and then at the end I saved the packet capture. So I had those packets on my way home. And that's the one I used to create the blog. And also something I didn't share yet, but I'll do it on my blog. I did some statistics in the plane in my second leg. Yeah, I ran some statistics. Yeah, the Vancouver to Toronto one.
Okay.
And so I ran some numbers based on the packet capture, and I created graph, or which MCS was used with which quantity, the retries per MCS. I did the how do you call this, the circle graph? How do you call them? The pie charts.
Pie charts.
Yeah. I did the pie charts to show distribution between one spatial streams communication versus two spatial streams. Nice. I did the same for the guard interval. And for the MCS used for all the Wi-Fi 6 data frames. So I'll share that on my blog. But that's interesting as well.
Yeah, that'll be interesting to see, because you're able to capture those from the frame captures. So I wonder with the with Wi-Fi 6 becoming more mainstream and having this infrastructure, being able to query all this information, I wonder if we'll be able to graph that natively with some of the APIs or some of the cloud managed vendors, if they're able to grab that information. That'll be really useful, and for us to determine how Wi-Fi 6 is working in an environment and be able to understand how some of the vendors use their own algorithms to determine like RU allocation and guard intervals, and it helps you understand how the Wi-Fi is working in your own environment. There's just a lot more information now with Wi-Fi 6 than the previous versions.
Yeah, and one thing I didn't get though during the demo is the multi-user communications, because I didn't, specify in my packet capture. I didn't specify that. So I saw a few trigger frames, but I don't have the data frames for those multi-user communications. So, I mean, I still have room to improve in my demos, but I think I improved it from the last time.
Yeah.
But I think I still have time, a little room to grow for the next demo.
Yeah, it's still not as easy to capture, because I know my captures, I don't get too many multi-user data frames, but I'm also just using 2 clients. So I need to get another Wi-Fi 6 client into the mix to try to create more variables there in order for that algorithm to kick in. But with all these updates coming out with all these access points, we're able to get more information out of the infrastructure itself. So we'll be able to see how this transpires over 2020, right? And see if 2020 is the year we can actually migrate with a lot of these features on the network.
That would be awesome. And one key thing for us will be to try to evaluate, when will Wi-Fi 6 start to bring good things benefits. The benefits on the Wi-Fi.
All right. Well, we're actually here to talk about 802.11r.
Nice.
Yeah. Now that we got the Wi-Fi 6 stuff out of the way, it's kind of exciting talking about that. But we want to go back a little bit and talk about some of the other amendments that have been rolled into the standard. And so I thought maybe 802.11r fast BSS transition would be a good place to start, because I think it's talked about a lot, but there's a lot of environments that don't have it enabled because of compatibility, right? And I think also for some organizations, they don't really know what 802.11r is, and they enable it because they're told, hey, you should enable 802.11r if your devices support it, and it'll improve your roaming. And so just wanted to talk about it briefly to mention how it works and how it would improve things in your environment, because this was an amendment that was published in 2008, right? So it's been a long time since this has been out, and surprisingly, not all devices support 802.11r, right? So that's one of the caveats to this is when you enable 802.11r, you risk blocking out devices that don't support it, because during the association process, the AP, the infrastructure, will look at the compatibility, and if the device doesn't support 11R, it just denies it from joining the network. And you'll get this nice little unable to connect message. Yeah, you'll get and when I was testing this yesterday, because I tried to get this denied message, right? It's you got to keep some old clients around. I don't have enough. What type of old clients do you have? I don't have any old clients. That's the problem. So what I wanted to do was use my MacBook Pro, because I know the MacBook Pros do not support 802.11r, right? But have you noticed that even though you've got an 802.11r network, the MacBook Pro can still connect to that SSID? Have you ever seen that? Is it adaptive 11R? There's adaptive, and then within Cisco, there's 2 checkboxes that you can enable, right? One is PSK, the other one is FT PSK for fast transition. So if you just leave off PSK and keep on fast transition PSK, the MacBook doesn't connect. I tried doing it, and it didn't work. But I could not get the deny message. It just I couldn't even capture the authentication frame. I couldn't get past that. So I'm not sure if I was just doing it incorrectly, but I know disabling PSK on the WLAN will prevent the MacBook from joining. and I was just using Cisco's. I was using a 3504 to test this out, and so, so that's just one of the things to consider is, do your clients support 11R? Because if they don't, if the majority of your clients don't, I don't think there's a reason to enable 11R just because you won't get fast transition working here for you. And so this was rolled into the 802.11 standard in 2012, and it's been part of the standard since. And then a lot of people will also talk about 802.11K and 802.11V as part of this, and we'll talk about both of those in a future episode. But in this episode 11R, we're talking about how it improves the handoff between APs as a device is roaming. And so one thing to note is the handoff is the same whether or not you have 11R. You have a client, it's going to reassociate. It's just depending if it's going to use fast transition or not. And so we can put some captures up on the show notes. I don't even know which episode we're on, Francois.
I think it's in 198, I want to say.
Yeah, 198. So if you go to clearsend.net/198, we'll have some captures you can take a look at. Were you going to say something, Francois?
No, I was going to, because you talk about 11R, but you didn't say what it is. So maybe we can.
It's fast transition. Fast BSS transition. That's what 802.11R is.
So maybe to put it into context, why did they introduce fast BSS transition?
Yeah.
If you think about it's related to roaming delays, roaming timing, and especially when you use security on the Wi-Fi network, you have to regenerate your encryption keys every time you enter in a new BSS. So pretty much every time you roam. And that can introduce some delays, especially if you use, .1x authentication and the radio server somewhere, and you have to do all those EAP, exchange. Sometimes this could increase the roaming delays to a couple of hundred milliseconds, and a couple of hundred milliseconds could impact real-time applications, such like voice or other type of real-time application. And so the IEEE guys they were just thinking about a way or a protocol that we could use to be more efficient in the way we transition to a new BSS. And what they were thinking is, instead of regenerating our encryption keys every time we roam, maybe we can just find a way to transfer those encryption keys from one AP to another, so we don't have to redo the whole authentication every time we roam, and we can be more efficient and faster. Hence the fast roaming, right? Fast transition.
Yeah, it's mainly with the .1x because of all those frame exchanges that occur between the client and the authentication server. And if you can imagine being maybe in a hospital where the doctors are utilizing voice over IP phones and they're roaming and they get this critical call and it's over Wi-Fi, you want to be sure that they're not losing those voice packets as they're moving from AP to AP, because that could be a matter of life or death. For example, if they weren't to hear certain words as they're trying to tell somebody what to do as they get to the situation, or maybe there's an emergency and somebody's trying to get to a specific area to help someone, and you're losing those packets. And I know you've been on voice calls, Francois, where maybe you don't hear some of the words, right? You only hear every other word, or it gets jarbled up because as you roam, you'll just start dropping some of those packets. And that's what they're trying to solve with 802.11r, is try to minimize the packet loss for these devices. And mainly it's around voice, but any other latency sensitive applications, this would apply to them as well.
Yeah, exactly. And you start to see a lot of latency application nowadays with IoT, devices rolled out on the Wi-Fi. So I think it's going to be more and more relevant. And if we want to implement, .1x security at large, it's a good thing to have 11R support for the future.
Yeah, and I'm going to try to add some captures or screenshots of the captures showing what the time difference is between roaming. Now, this is in my lab, and I was talking to Francois about this before recording, is trying to get trigger a roam in my house to do the capture. But being in the Bay Area, I don't have a pretty big house. So I have to put my APs on really low transmit power, and then I have to create some attenuation between the AP and the current AP and my phone to try to trigger a roam to the target AP. So I wanted to show some of the time differences that you can notice between a non 802.11r network and then with 802.11r enabled, because it's a matter of milliseconds difference that you get, and on Wi-Fi that milliseconds matters, right? So even though it's, to us, maybe milliseconds doesn't mean that much because it's such a short time frame there, but for wireless communications that could mean losing packets or not losing packets.
Yeah, and usually with 11R, you're able to go down to the tenths of milliseconds versus the hundreds of milliseconds. So it's really impressive if you make it work.
Yep. So fast BSS transition, as it's called in the 802.11 standard, it's part of the reassociation process within what's called a mobility domain. And so a mobility domain it's basically a number of access points working together in the same infrastructure, or ESS. So if you've got, say, a Cisco controller and all your APs are associated to that controller that join there, that would be your mobility domain as you configure it on your controller. And within the frame itself, the beacon frame, if it's advertising 802.11r, there will be a mobility domain information element which has a unique identifier for that mobility domain. And so that's, if you're trying to troubleshoot and figure out why the 802.11r is not working correctly, it could be maybe the mobility domains don't match. That could be one thing. And there's other things to look at too, but just to start off, it's the 11R is really focused around the same mobility domain.
Yeah.
And so some of the key terms that I think that we should know about is there's FT for fast transition. You have what the standard calls FTO, which is the fast transition originator. And that is the device that's trying to roam from its current AP to a target AP. And then there's two methods in which roaming can be done, or fast transition protocols that are used, which is over the air, which is the originator communicating directly to the target AP as it roams. And then there's over the DS, which is the originator communicating to the target AP through its current AP, and then using the wired infrastructure to communicate with it that way. And so we'll go into what the differences are, what to look for, and what's exactly in a fast transition frame, because there's actually quite a lot to consider when you're looking at the frames itself and the operations of 802.11r.
It's a nice, it's very nice protocol, very nicely engineered protocol, I should say.
It is, yeah. I think it's something that should be widely supported. And we talked about this, Francois, earlier, is with Wi-Fi 6, the devices are going to need to support, over the air fast transition. And so we'll take a look at those frames. I think the more you look at the frames, you get more familiar with it, and then you'll see the little differences in the different protocols of fast transition that's being used. But it's important to understand the frame exchanges that occur and what's communicating with what and what other messages happen in between for a successful roam, right? Yeah. And so I guess we should talk about the initial association, right? I think we have an old episode talking about association and four-way handshakes and all that, right? So you have your device, it's going to do a probe request on the wireless network, then you get a probe response from the AP. This is the initial association of a fast transition network. So that initial exchange will be called the Fast Transition Initial Mobility Domain Association. And so there's going to be that compatibility check, both client support 11R. It's going to go through the authentication and then the association, right? And then it's joined. From that point forward, as it's joined into the network, and if it wants to roam, it can then use the fast transition protocols to roam to another AP. And so
so initially you do the four-way handshake to get your keys.
Yeah. So you can do the four-way handshake if you're using a PSK or .1x, and then you go through authentication. Yeah. You could also have fast transition enabled without PSK or any security. It could be an open network. It's just a lot more simpler with an open network, right? You just have the reassociation frames, and then it joins to the target AP. But the real benefit for roaming comes with using the keys, because it's going to somehow like cache the keys, and it's going to make that a lot more simpler. And there's actually a lot of detail within the fast transition frames about the keys. I don't know if we'll go into all the details about the keys, but we'll try. But we're going to talk about right now the two methods in which the fast transition protocols, right? So again, there's over the air, which is the one that's going to be more widely supported. And that's when the device communicates directly with the target AP. And the way that looks is when the AP decides that it wants to roam to a better AP, or an AP with a better signal, right? Yeah. Whatever the algorithm is for the device to trigger a roam, it'll start doing a probe request, or if you've got the other amendments enabled, right, it'll have a neighbor list. And then that's when it sends a reassociation request frame. And that is a special frame. It's a management frame, not an association, but a reassociation request. And so when you're looking at that, if you've got a capture in front of you, the reassociation request the most important fields or information elements within that frame, there's the RSN information element, there's a mobility domain information element, and also a fast BSS transition information element.
Yeah, I'm looking at also in the reassociation request, the clients also specify the SSID he wants to connect to, or is connected to. And I just noticed the one you have in your capture is flamethrower.
Yeah.
Are you working with Elon Musk?
Just throwing out frames there. That's my SSID, flamethrower.
Awesome. Anyway, go on. Sorry.
So within the reassociation request, if you look at the details, there's actually a field there that says current AP, and it'll have the BSS ID that the client is currently associated to. Right? So that's important to know, like where this client is coming from. And then the RSN information, there's going to be keys that are going to be transferred or checked against on the infrastructure side. So it'll include the PMK ID, which is important for the fast transition. And then there's Cipher Suites that you should look at. I'll put this in the show notes because it's not going to be easy for me to read off over a podcast, and it won't make a lot of sense. But it's important to know that these pairwise Cipher Suites that's used, depending on what we're looking at here, if it's over the air or over the DS, those will change. So that's one thing to note. And then under the mobility domain information element, here is where you figure out if this is a fast BSS transition over the air or over the DS. If it's over the DS, the bit will be changed to 1, and that's how you know it's over the DS. If it is set to 0, that is an over-the-air fast transition protocol being used. And so when you're looking at that mobility domain information element, that's one important thing to look at. And you could create a filter and make that as a column within Wireshark. That's pretty easy to do. Then you have the fast BSS transition information element, which includes, which will include the nonces there that's required in order for the transition to be done faster, right? That's how they minimize the time here. So you've got these keys that are identified in the fast BSS transition. So you've got the PMK-R1, the A nonce, S nonce, and that's critical for that fast BSS transition for the security portion. That's how they minimize the time, because if you don't have 802.11r, then you're going to have to go through the key exchanges again.
Well, if you think about the four-way handshake, right? And if you think about the two messages in the four-way handshake, that's pretty much what they do here, but they embed those two messages within the reassociation request and reassociation response. So if you look at the reassociation request and the information elements you're talking about right now, the fast BSS transition, you will find all the information that, they are exchanged during the first two message of the four-way handshake. So the A nonce, S nonce, MIC number, PMK, and so on. And so that the keys can be, transferred to the new AP pretty much.
Yeah. And so that's where that efficiency comes in with the time. And I think that's really what we're looking for with 11R, because if you're not using it, you're just going to have to go through everything again and again. And so it delays the time there. Now, when you look at the response coming from the AP, it'll be a reassociation response frame. The important thing to note here is there should be a status code, and if everything goes right, it'll say successful. And so you'll see that within the reassociation response frame, along with the RSN information element. And then it has all the other information elements as well, and everything else should match there. And so that's a simple way of looking at 802.11r and the reassociation frames. And that over the air, you just see the reassociation request and response. Now, when it comes to over the DS, there's actually a couple more other frames, which we should talk about, because I did capture this on my infrastructure here. The action frames are kind of interesting to see how the communication is done between the client, its current AP, and then the target AP, because that transition communications goes between the APs and the infrastructure, the wired infrastructure. And so the additional frames that are added here is you've got this another management frame, but it's a subtype of action. So it's an action frame. And this is sent before the reassociation requests. And so you have an exchange of action frames, and the category of the action frame will be a fast BSS transaction with a code of fast transition request. So you have the device sending a fast transition request through its current AP, and the actual frame will list out the target AP MAC address. So that's how it determines where to send this fast transition request. And then you still have those information elements, your RSN, mobility domain, and fast BSS transition. The biggest difference here is you got these action frames going across your wired infrastructure between the client and the AP. And then that'll include your S nonce. And then as the reply from the target AP, it'll be a fast transition response, still an action frame from the AP going towards the client using the wired infrastructure. And it'll have a status code of successful if that all goes well, right? And so after those two action frames, then you go into the reassociation request and response again. And so I feel like over the DS just adds a little latency because of the additional frames it has to send. But
it takes looking at your packet, it takes 38 milliseconds for the over the DS, and I think it was 12 milliseconds for over the air.
Yeah, so it's all going to depend on your infrastructure. And Francois, I think some of that delay too is because I'm using I have an AP in my living room and an AP in my garage. So to get connectivity to my AP in the garage, I use power inline. And that connection is not very good.
It's not a fiber.
No fiber in my house. No. So it's not quite the best infrastructure, but at least I could introduce some delay there to show you what that looks like. And if you want to look at the total time it takes within Wireshark, if you're looking at the frame capture, if you go to view and then time display format, you can change that to seconds since beginning of capture. And then you can set how many seconds you can do. Seconds, tenths of a second, hundreds of a second, milliseconds. I have mine set to milliseconds right now. If you do seconds, it'll just be 0 because we're talking about sub-seconds here. Unless you really have delays and it takes seconds. But if you're troubleshooting, you could see that and see the how long it's taking for the actual transactions to occur. And so that's how Francois is able to see the difference between over the DS and maybe over the air.
Yeah. Okay. So are you? Will you share these packets with the listeners? Okay.
Yeah, I'm going to share the frame captures. If some of you are unable to create the captures yourself, you can see what I've created in my lab using Cisco 9115s. And I have them in Flex Connect mode.
Okay. And they're very interesting. You can see the different information elements.
Yeah, it's really interesting. It's good for also if you're studying for the CWAP or the CWSP. The CWSP will go more into the security keys that's involved. And I think we'll probably write something up about security. It's almost its own podcast episode talking about security keys, because I think there's a lot to go through when you're talking about exchanges of keys and what keys to look at and all the different names of these keys and how they're generated. So I think we'll leave that for a different episode. But if you're studying for those 2 certifications, this is a good way to understand the frame exchanges that occur, the different protocols that are used, because you could use over the air or over the DS. You have to get the wired infrastructure involved, because if you're using over the DS, those frames will go across the wire. And then you're looking at troubleshooting what kind of delay you're looking at, what frames you should expect after reassociation occurs, right? Are you going to see a 4-way handshake? Are you going to see EAP frames, for example? What EAP frames are you going to see? So it's a good way to really understand how 802.11r works, because when you're talking about, let's say, over the air, right? Over the air is a fast transition protocol, and over the DS is also a fast transition protocol. Over the air, it's you're going to do authentication with your RSN, the robust security network. And when you're doing over the air, you're going to create a fresh PTK in advance of the reassociation. So that's how do you capture that? And that's usually the PTK is in the beginning, in the initial association. And because it's one mobility domain there, that's how the reassociation request or the reassociation is done or improved. It's faster, right? Because those keys are already established. You're just going to create some keys will be recreated as part of the reassociation. What do you think, Francois? Are you using 802.11r often in your networks, or I know you work in a lot of warehouses, so I'm not sure if those devices are 11R capable.
Yeah. So if we talk about client supports right now, the limitation we have is that, not every device supports it. If you're in a very controlled environment and you're going to have a lot of iOS devices, for instance, that these devices support 11R. But in the, if I work for, let's say, in a warehouse, or if I work in a public venue, you are not going to be able to leverage those, 11R in those environments because of client support. And also in public venue, usually it's just an open SSID, so you don't necessarily need, the faster transition because you don't have any encryption anyway. So you will just get reassociation request response anyway. So I just when I use it, I just make sure I test it though, and then I make sure I let the customer know about the implication of enabling the protocol. And some customers just decide not to enable it. Some others just decide to enable it and make sure that they communicate with whoever is responsible of bringing new devices, so they know that, if they want to introduce new Wi-Fi devices on the corporate network, they'll have to go through some tests to make sure that it supports, different features, including 11R. So you can do it different way. In the future, what's great is that we're going to have more and more devices supporting 11R per standard. And this is due to the fact that if you want this is due to the Wi-Fi Alliance certification programs, and especially the Wi-Fi 6 certification program. So in the Wi-Fi 6 certification program, the Wi-Fi Alliance try to include some of these features by default. So we talked about WPA 3 before. So WPA 3 will be mandatory for Wi-Fi 6, and another certification called Wi-Fi Agile Multiband is also mandatory for Wi-Fi 6 client devices. And if you look at this Agile Multiband certification, you realize that stations have to support over-the-air fast transition. Yeah, and a couple of 11V and 11K features as well. So which will help us to have client devices that roam faster and take better roaming decisions.
Yeah, because remember, it's still up to the client to make these roaming decisions. We have other amendments to help those clients determine where to roam, but we don't have a mechanism to say, okay, here's when you're going to roam, and you're going to roam over there. And like I said, in my lab, I still had a problem trying to get my iPhone and my S10 to roam when I wanted it to roam. Right? I would go from upstairs to downstairs. My garage is downstairs, and I would try to put as much attenuation as possible between my device and the current AP it's associated to. And I would be standing so close to the target AP that it just would not reassociate, because it still thinks, negative 72 is great signal, even though I've got a negative 40 signal right next to it. And so it's still up to the device. You need to figure out the device capability. If you don't know what the device capability is, you could do a test, enable 11R, and try to do a frame capture of that device. And you should see in the frames from the device whether or not the mobility domain element is there, or the fast BSS transition element, information element is there. If it is, it supports 11R. If it's not there, then that device is not going to support 11R on that network.
You can also do capture the association request coming from the clients, and should tell you. There's a great tool on the WNPI called Profiler to do that. It will just create a fake SSID that supports everything, including 11R, and then you can just set it up on WNPI and then use your client device to connect to it, and then you will get a summary on the WNPI telling you if it supports it or not.
There you go.
Yeah.
And when it comes to support or troubleshooting, there's a lot of different places in these frame exchanges where there could be a failure, right? Different rejection messages. And so the first one is if the mobility domain element doesn't match between the AP and the client, and you'll see this in the beacon and probe response frames, then you'll get a rejection. And in the standard, it says, they call it status invalid MDE, and that's mobility domain element, I believe. There's other areas where you could get rejections. There's the RSN, and if there's no negotiated authentication key management, then you'll get an invalid AKMP. Now, if it doesn't contain the correct key in the fast transition element, then you'll get an invalid FTE. So I haven't seen a lot of these when I've been looking at fast transition, but you can also get an invalid PMK ID if within the RSN information element there's an invalid PMK R0 there. You could you could have the AP reject your fast transition request, and that's a request declined rejection message. There's also a R0KH unreachable. And then there's a status invalid pairwise cipher if the pairwise ciphers do not match. And so those are different rejection messages that's defined in the standard, and whether or not that's actually implemented on the vendor side, that's a different question. Because like I said earlier, when I was trying to get my MacBook Pro to join a fast transition enabled network, I could not capture any rejection message. It just wouldn't associate. And I could see the probe response and the probe, I could see the probe request and the probe response, but I didn't see anything beyond that.
Maybe, I'm thinking maybe it's if you have, two APs in the same network, providing the same SSID, but you have the SSID configured differently between the two. Like one supports 11OR, the other one doesn't, but they have the same name.
Yeah.
I'm thinking maybe that's when you have some of these.
I could try to do that. And I'll see if I can try to generate some, maybe one that doesn't have any security and one that does, and see if I can get this invalid PMK ID. I'm not sure how an AP sends a fast transition request decline, but it'd be interesting to see like how you get these different rejection messages. But usually this is due to misconfigurations on the network for some reason, right?
Yeah.
It's more of an infrastructure configuration thing. So I guess to recap some of how this works, because I think the takeaway here is the sequence of frames that are exchanged between the client and the AP or the target AP, right? Current AP and target AP. You've got your fast transition authentication sequence of frames, right? You've got either over the DS, the fast transition request and response, and then there's the reassociation request and response. Over the air, it's going to be a reassociation request and a response. And then after that, it's like any authentication frames that need to occur. But it should be a successful session after that. You can just transfer data after the reassociation response. It's if you're initially connecting, that's where you're going to have that four-way handshake and the EAP exchanges if necessary. But yeah, there's a lot more to it, especially when it comes to the security side of things. And for me, the last time I really looked at the key exchanges was back in the CWSP when I was studying for the CWSP exam. But I think it's important to go through the Cipher Suites, which I think we should do in a different episode, talking about security and what that looks like for like PSK and 802.1x, because we'll also want to see some of those packet captures from the authentication server as well.
Yeah, and I think it's related to the four-way handshake as well, because some of the elements are similar. If you talk about security and want to go through the different keys of them, so yeah, maybe we can talk about them, and then talk about the S-nonce, the PMK, and how the AP is using that to calculate the keys.
Yeah, and there's different suite types too that we didn't talk about. So with the Cipher Suites, with open system authentication, which is going to be what we use mainly today, there's two different suite types, and I'll put that in the show notes. But excuse me, we remember when there was that that vulnerability with WPA2 and the key exchanges.
Crack.
Yeah, remember crack. So then now there's this talk about moving to SAE, right? The stronger security exchange. That you'll see three different suite types. So depending on which one you're using, with SAE, there's going to be a completely different suite type, and you could see that in the mobility domain or the RSN information element. And so that'll help you determine what kind of security suite type you're using in your wireless network.
Awesome.
Yeah. So those exchanges are slightly different when you talk about WPA3. Also, with I haven't even tested this with OWE, what that looks like as well. Very different scenarios to test with very slightly differences between each, but more or less the frame exchange is about the same with the reassociation request and the reassociation response. The only main difference is if you're using over the DS, then you got those fast transition action frames that occur before the reassociation frames. But that's as far as I decided to dive into.
Yeah, no, that's awesome. That's awesome. In the show notes, we'll put some of the diagram from the standard.
Yeah, the standard lays it out pretty well as far as which frames are going where and how many of them. So we'll definitely include those in the show notes, and then add any PCAP files for you guys to try to follow along and see what I've been seeing in my lab. So if you guys do have any questions, you could, in the comment section of the blog post, you could go to cleartosend.net/198 and let us know there, or hit us up on Twitter at cleartosend. One thing I want to remind everyone is we are still in the voting process for the IT Blog Awards. Francois, we're finalists in the podcast and video series that this IT Blog Awards that Cisco is hosting. If you guys could do us a favor and vote for us, it only takes about 2 to 3 minutes. If you go to cleartosend.net/vote, it will bring you to that page.
How convenient.
Yeah, very convenient, right? Try to make it as easy as possible for you, because the Cisco link is, I'm not going to try to pronounce that at all.
Yeah, the 705E something.
So I made it easy for you guys. It goes straight to the voting page where you can vote for us. We also have other friends in different categories that are listed there. So I think it's great to see people in the wireless community making it to the IT blog finalists as in the IT Blog Awards. So that's great.
It's not easy.
No, it's not.
I see Wi-Fi Nigel, I see Wi-Fi John, I see Rasika, but I also see, Hayden. So you have to make some choices. It's not easy.
No, yeah. You're going to have to not say who you're voting for, but
yeah.
I would say go out there and vote anyways, even if it's not for us. I think it's great to recognize some of the people here in the community that have been contributing. I know, Francois, you've been contributing quite a bit, and it's really great to see what you're able to find when analyzing Wi-Fi 6, because it's helping us really learn how to look at these the new protocols, and it's conversations like this, Francois, when we talk about like 802.11r and frame exchanges and how it actually works. And so this is how, as a community, even if you want to start participating, you can do what I've done with 802.11r and just kind of do it as your for yourself in a lab. That's how you learn how to do frame captures, and then try to put it in a way where it makes sense to you and for other people, and be able to confirm.
You might discover different things with different devices and be like, hey, that's different with this guy.
Yeah, exactly. And you would think fast transition would just work, right? If there's an AP with a stronger signal. No, that's not.
Yeah.
Not yet. Yeah. Maybe when I turn on the other protocols. So if you want to know like how I did my test, I was initially using two different MIST APs. And then I found that, okay, the only thing I could configure with fast BSS transition was whether or not it's on or not. And by default, it's just going to use over the air. So I wanted to test out different settings, right? I wanted to test over the DS. So I turned on my controller, associated my Cisco APs to those controllers. I put the APs in Flex Connect mode because I wanted to capture frames from on the wired side of things, and I didn't want them tunneled. I didn't want the traffic tunneled back to the controller. And then I disabled a lot of other features. I disabled all Wi-Fi 6 features. I And the reason why I did that was I could not get it to roam, or I was not expecting it. I wasn't able to see the roaming process work efficiently. So I don't know if there was something with the version of code I'm using, but I had a harder time with roaming with Wi-Fi 6 enabled. And so I turned off all of those features. Turned off Wi-Fi 6.
You're so bleeding edge.
That's the problem I run into in this lab, right? And then I turned off the other amendments. So I turned off 802.11k, 802.11v. I turned those off because I didn't want, initially I had them on, and then I started noticing, I should probably turn off these other amendments because I saw 802.11v frames, for example. So it was helping my device roam a little bit more properly. And then I just settled on 802.11r to make that work. So that's how my test lab went. So I'll describe that too in the show notes.
All right. Did you hear my daughter knocking on the door? All right. So
that's the signal, guys.
Time is up. Yeah.
So if you guys want to know more, head over to cleardescend.net/198. Looking forward to what you guys have, and we'll see you guys on the next episode.
See you guys. Have a nice week. Bye-bye.
Bye.